A 100 gram of copper block at 20 degrees C is added into a large amount of steam at 100 degrees C. Find the mass of steam that condensed to water. There are two substances in the systems given in the questions. One is copper, another one is a steam. The copper block, initially the temperature is at 20 degrees C, and for the steams, initial temperature is at 100 degrees C. So that means the heat flow, the net heat flow will happens from the steams to the copper. Copper will gain the heat and the steam will lose the heat. In the questions, it says that it is a large amount of the steams in the system. What is the implications of this large amount of steams? Because the coppers, after they absorb the heat, the temperature will rise from 20 degrees C to the higher temperature. If the quantities of the steams in the system is large, that means this copper block will increase its temperature until 100 degrees C. Okay, and the steams will maintain at 100 degrees C. And those mass of the steam that condense to water also will maintain at 100 degrees C. This is the meanings of the large amount of steam. This is the implications from the large amount of steams. So that means the final temperature for the systems is at 100 degrees C. Now we can calculate what is the heat absorbed by this copper and what is the heat, total amount of heat lost by the steams. So the formula for the copper is QC equal to mccc delta T, where the subscript C means copper, and this C, of course, it is referred to the specific heat capacity. Delta T is a change of temperature. For the steams, Qs equal to MSLV. Subscript S means steams, and this V means vaporization. So LV is a specific heat capacity of vaporizations. Since the heat exchange happens between the copper and the steams, and from what we analyzed just now, we know that the heat loss by the steams will be absorbed by the copper. So these two quantities QC and QS must be equal. So now we write the QC and QS in the explicit form. We'll have the second line. MCCC delta T equal to MSLV. But now since we want to find what is the mass of the steam that converted to water, so that means we want to find this MS. So now we change this MS as a subject. We will get MS equal to MCCC delta T divided by LV. So we change this MS as a subject of the equations. And MS is the quantities that we want to find. Now we can substitute the value for the MC, which is a mass of the copper block, is 100 gram. So in kg it is 0.100, and Cc is a specific heat capacity for the copper, which is 390 joule per kg per Kelvin. We can get this value from the internet or from the books. And the change of the temperature for the copper is from 20 to 800. So that means it is 100 degrees C minus 20 degrees C. And LV is a specific latent heat of the vaporizations. There's another value that we can get it from internet or from the books. So it is 2.26 times 10 to the power 6 joule per kg. So if we press calculator, we will get the answer for the MS, which is a mass of the steam that condensed to water. It is 1.38 times 10 to the power negative 3 kg, or equivalent to 1.38 gram. Now please take note that this water that condense from the steams to the water, its temperature is maintained at 100 degrees C because the quantities of the steams in the system is very large. large enough to increase the temperature of the copper from 20 degrees C to 100 degrees C. At the same time, it will prevent, it is possible for it to maintain the temperature of the condensed water, maintain its temperature at 100 degrees C. Okay, so the final temperature of the system is 100 degrees C, and the system, we know that it has a copper block, it has a steams, and it has the water condensed from the steams. 3 of them all are in the 100 degrees C. This is the final temperature of the system.